Welcome. We have here a mass 1 coming at mass 2 in one dimension, colliding with it and giving some momentum to it, and we're going to have an elastic collision. In our elastic collision, we have energy being conserved. Energy conserved means that, right, 1/2 of m1 v1i squared plus 1/2 of m2 v2i squared equals 1/2 of m1 v1f squared plus 1/2 of m2 v2f squared. We also have that momentum is conserved. Which is that m1 v1i plus m2 v2i equals m1 v1f plus m2 v2f. So we want to look at specifically the case where m2 is at rest because that makes things a little bit nicer, a little bit easier for ourselves. So we can construct a table of knowns and unknowns. Because what we want is we want to have a general set of equations given a couple of interesting things. So the first thing is that we know m1, we know m2. We're just going to call m1 and m2 as that. We know that our v1i is known, we're given it, and we're just going to call it vi to avoid a little bit of subscript drama. And then we know that our v2i is 0. What we won't know, or don't know right now, is we don't know our final velocities. We don't know v1f, we don't know v2f. Again, to avoid a little bit of subscript drama, we're going to call them just then v1 and v2. So, if we go through this, we can look at our momentum conservation. And rewrite given all of this, and then we'll show what our unknowns are in this. So we have m1 vi plus 0, so we don't need to write that, equals m1 v1, v1 being the final velocity of v1, plus m2 v2. And then if we look at our energy, we have 1/2 m1 v sub I squared equals 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Our unknowns are v1, v2, v1, v2. So we have 2 equations and 2 unknowns. So this is solvable. And now we're going to solve it in a general sense. So we want to use momentum, and we want to solve for v1 in momentum. So the first thing I can do is I can bring this m1 v1 over to the one side, and I can bring everything else to the other side. So it's m1 vi minus m2 v2, and then I can divide by v1 to get v1 is equal to vi minus m2 over m1 v2. Awesome. So then now that I have this, I can plug it into here, and if I plug it into here, we'll see that we only have one unknown left. So we can plug in v1 is equal to negative m2 over m1 v2 plus vi into our energy equation. So when we do that, we still have this side stays just the same, 1/2 m1 vi squared equals 1/2 m1. And now we have to plug all this in. Vi minus m2 over m1, v2 quantity squared, and then plus 1/2 m2 v2 squared. So now that we've done that, we have V2 as an unknown, V2 as an unknown, and everything else, 1/2 M1 VI, 1/2 M1 VI, M2, M1, 1/2 M2. These are all our knowns. So we're left with one equation, one unknown. It's a little bit hairy, but let's get through it. So the first thing we can do is we can kind of simplify by dividing by 1/2 M1. So if we do that, we cancel out M1, 1/2, 1/2, 1/2, and then this 1/2, and then we divide by M1 here. So what we get after all this is we get VI squared on this side. And now it would be probably nice to FOIL out all of this. So VI times VI gives me VI squared, right? Minus 2 times the sum of these two, or the multiplication of these two. So we have M2 over M1. And then we have VI V2. And then we have plus M2 squared over M1 squared V2 squared. And lastly, we have plus M2 over M1 V2 squared. So right, this is our last term. This is the last of these terms, middle and first. And then what we can see is that if we subtract V1 squared from both sides, or VI squared from both sides, sorry, then we get that they cancel out. So now I have 0. And we'll see that we have a lot of common factors once we brought these two out. So I have negative 2 M2 over M1 VI V2 plus M2 over M1. And we can write this as quantity squared. V sub 2 squared plus M2 over M1 V2 squared. So the first thing we can do is we can divide by M2 over M1. If we do that, right, it's 0 on this side, so that doesn't change anything. Cancels a factor of this, a factor of this, and a factor of this. A little bit more controversial is we want to consider if V2 is equal to 0. If V2 is equal to 0, our block is starting at V1 and continues through. And the only way to conserve momentum then is that, right, if V2 is 0 and V2I is 0, then V1I and V1IF would be the same. So this is if it misses or if it Shadow Cat from X-Men just phases right past. So this would be a miss case. So we can discard that. Right, it's super trivial. If we can discard that, then we can treat V2 as not being 0, and then we can divide by V2. Right, again, we try not to divide by V2 whenever we can, because otherwise we're dividing by 0. And if we do this, now that we've done all of this, right, let's rewrite it ourselves. So we have 0 is equal to negative 2 VI plus M2 over M1 V2, and I can write this 1 as M1 over M1 V2. So I can bring this 2 VI to this side, and then I have M1 plus M2 over M1 times V2. So solving for V2, which is, right, the final of mass 2, I get 2 M1 over M1 plus M2 VI, or this is then V1I. And so this is my first of 2 equations. Going back here, now that I know this, I can plug my energy result into my momentum result. And I have that V1 final is equal to VI minus m2 over m1 times what v2f is, which is 2m1 over m1 plus m2 v1I. So we can cancel out the m1s here, and then just as I did, right, m1 over m1 is equal to 1. I can do m1 plus m2 over m1 plus m2 is equal to 1. So showing that, we have v1f equals m1 plus m2 over m1 plus m2 vi. I've just rewritten 1 as this, minus 2 m2 over m1 plus m2 v1I. So I get then that my v1f is m1 plus m2 minus 2m2, which is equal to m1 minus m2, over my common factor of m1 plus m2, times my initial velocity, which is also known as mv1I. So these two equations only work under specific circumstances. We're going to write it twice, write it on each. Right, this is only when v2I equals 0. Only when v2I equals 0. But that's how we use energy conservation, momentum conservation to come up with these two equations. If you have an elastic equation in which v2I is equal to 0, feel free to just use these equations. This is kind of a hairy proof, so we don't need you guys to do it every single time. And then look for another video for when v2I is not equal to 0.